Let's take a look at number 19. And let's refresh our memory on our steps. This is solving radical equations. Step 1. Get a radical by itself unless it creates a fraction. So do everything you can to get it by itself until you get to the step where you create the fraction, then don't do that. Step 2. Raise both sides to a power equal to the index. And step 3, if more radicals, go back to step 1. Step 4, solve for x, and that's pretty vague, but usually in intermediate algebra you're solving a linear equation, but it's possible. Well, no, it isn't possible. It's more college algebra. College algebra is where it could be a quadratic equation. And then step 5, check your answers. So let's look at this problem. Now, first thing I want to mention before we actually dive into this problem is that if I have something that looks like this, whatever number's in this little slot right here, that's called your index. In this case, I put a 5 in there, so our index would be 5. If you have a square root, for example, then your index is going to be 2 by default. So let's work this problem. Get the cube root of x minus 4 equals 2. Okay, first step, get a radical by itself. Well, the radical is by itself, so nothing to do there. There's no numbers in front of it, no numbers after it. Step 2, raise both sides to a power equal to the index. The index here is 3, so we're going to take both sides to the third power. Now, when your index matches the power you're raising it to, they're going to cancel each other out, and you'll just be left with what's underneath the radical. And 2 to the third over here gives us 8. Now, step 3, if more radicals, go back to step number 1. I don't have any more. Step 4, solve for x. Well, here I take negative 4 to the right side, becomes a positive 4. And we get x is equal to 12. Now, step 5, check your answers. So if I put the 12 back up in my original equation, I get, replacing the x with 12, I get 12 minus 4. And this is more of a question mark. We're wondering if that's true. That gives us 8. And if I do the prime factorization of 8, that's 2 times 2 times 2. And our index is 3, so I'm looking for a set of 3 of something. Well, here's 3 2s. So those are going to come out as a single 2. And I see that I get these the same. If these are the same, then your answer checks. So my answer is indeed x equals 12, which is B, as in Bill. So let's check that. 19B.